We present ExCap3D, a model for expressive 3D scene understanding via object captioning with varying detail. ExCap3D detects objects in 3D scenes and describes them at multiple levels of detail. The object level caption describes overall object semantics, while the part level caption describes fine-grained object parts and their appearance. Existing datasets that describe objects in 3D scenes primarily described high-level relations with nearby objects, with limited local detail. This single level of detail captioning limits their expressivity. In contrast, we describe objects at both their object and part level of details, including rich part and appearance information, improving upon the expressivity of these datasets. ExCap3D takes as input a 3D scene and uses a transformer-based backbone to predict 3D instances and their context features. The rich instance-aware queries are input to two separate captioning heads, which predict object and part-level descriptions of the objects. This is supervised with ground truth captions for both levels of detail. To model an object as a sum of its parts, we condition the object-level generation on the hidden states of the part-level captioner. At the same time, we project the hidden states to a lower dimensional embedding space and enforce semantic and textual consistency of the predicted captions through additional proxy losses. To enable the task of multi-level captioning, we generated the ExCap3D Dataset. We use 3D scans from the ScanNet++ dataset along with their ground truth semantic annotations and multi-view DSLR images. We select multi-view crops of the objects in the scene and their parts. We then caption each crop using a vision language model to obtain per-view captions of the objects and their parts. We combine the captions from different views using a large language model to obtain the final captions at both object and part levels. We compare our ExCap3D dataset with existing datasets that describe objects in 3D scenes. Our dataset improves upon these in the number of descriptions, objects described, and semantic classes while introducing a part level of detail. We compare our method with 3 state-of-the-art dense captioning baselines by training them on the object and part level captions separately. Our joint approach produces captions that are more consistent and complete than all baselines. Our part-to-object information sharing produces multi-level captions that are coherent and descriptive, and our semantic and textual consistency losses encourage the two levels of descriptions to be consistent with each other. We compare quantitatively against baselines, measuring the Cider score at a threshold of 0.5. Our method outperforms all baselines, particularly at the part level of detail, where we provide complete and coherent part level descriptions. Thank you for watching.